this circle diagram, we have a motor of rated power of 20 HP, rated voltage 400 volt, 50 Hz, 3-phase induction motor. So here there are two tests that are given, no load test and block rotor test. First, for initial calculations, we have to take no load test. So at no load, our input current, that is I naught, is equal to 9 amps and our voltage is 400, which is rated. Here we got 9 amps and we have to find the angle phi naught. To find phi naught, the formula is cos inverse. Here since they have given power factor, so it will be cos inverse of the power factor, that is 0.2, which is equal to 78.46 degrees. So no load calculations are done. Now we have to go for block rotor test. In block rotor, our current at 200 volt is 50 amps. So we have to convert it to what at rated voltage, what is the current, that we have to find out. So here at 200 volt our current is 50 amps. Now at 400 volt, that is our rated voltage, what is the current we have to find? It will be 400 into 50 divided by 200, which is almost equal to 100 amps. So at rated voltage at block rotor test, we will get 100 amps if we keep rated voltage. So ISC is equal to 100 amps. What is the angle of ISC? That is phi SC. Since here they have given here 0.4 power factor, we'll take phi S is equal to cos inverse of 0.4, which is equal to 66.42 degrees. Now at this rated voltage, we have found short circuit current and short circuit the angle. Now we have to find the block rotor, the short circuit power, that will be PBR, block rotor, is equal to root 3 VL IL cos phi, which is equal to root 3 V, that is 400. We are doing this, we are calculating the power at rated voltage, so it will be 400 into 100. At 400 the current is 100, so into 100 into our power factor, that is 0.4. So we get the value of 27,720, almost 27,720 watts. After this initial calculation, we have to do the in no load and the block rotor load current phasors. So to do that, here our y axis is our voltage axis and x axis is our current axis. So take current, since here the current is 100 amps and almost 9 amps. Here we have to take a suitable scale, since it is 100 amps here and 9 amps here, so we will take a scale of 1 centimeter is equal to 10 amps. So here we have to write 10, 20, 30, 120, till up to 120 I'm going to write. Now let us take the origin as O. To draw no load current, first we have to take the angle with respect to our y axis. So keep protractor such that the 0 is on y-axis from the origin. For our no load condition, the angle is 78.46. So draw a point of 78.46. Now here the no load current is 9 amps. So converting it to centimeter scale, if 1 centimeter is equal to 10 amps, then 9 amps is equal to how much? It will be 0.9 centimeter. So keeping the 0 of scale at O and the line passing through the point whatever we did, draw a line of 0.9 centimeter. So this line is our O dash. Now let us do the block rotor current line. So the block rotor current is 100 amps, which is at an angle of 66.42. So keeping a protractor such that it is 0 on y-axis, draw an angle, mark a point at angle of 66.42. Since this is 100 amps, 1 centimeter is equal to 10 amps, then 100 amps is 10 centimeter. So from the point O passing to the point whatever we did at 66 degree, draw a line of 10 centimeter. After this is our point A. From point O dash to A, draw a line. So this gives our output line. From point A, draw a line parallel to y-axis, draw a line down up to our x-axis, and from O dash draw a line which is parallel to our x-axis. The point where this line which we draw from O dash intersects at this A D, this point is our point F. This is D where it intersects at x-axis. Now we have to draw a perpendicular bisector for O dash A. So we have to take from O dash A arc and join the points such that it passes through the x-axis, the line, and little bit above. Now the point where it intersect, where the line intersect at this upper line is point C. Keeping compass on point C, make sure that the length is of O dash and draw a circle. So this circle passes through the point A. In this question they have given that the motor rating is of, which means that the power output is 20 HP. So we have to draw a line from A per, uh, parallel to our y axis on the above. So that will be our A dash. So to draw the line, if the watt is given, we can do it directly, or else if it is given in HP, then we have to convert HP to watts. So 20 into 735.5, which is equal to 14,710 watts. This is our output power. This is our rated output power. So we have to draw this on the top. So for that we should be knowing the power scale. Here in the block rotor test, initially we have done the power of block rotor. So it will be 27,720. So take a power scale. Here AD, the line AD represents our input power at block rotor condition. So it is almost equal to 4.2 centimeter. So 4.2 centimeter is 27,720 watts. We have to check the power scale. If 4.2 is 27,720, then what is 1 centimeter? So it will be 27,720 divided by 4.2. So 1 centimeter power scale is equal to 1 centimeter is equal to 66,000. Sorry, it is 6,600 watts. So now we have got the power output is 14,710 watts. So what is the centimeter according to this value? That will be, if 6,600 is 1 centimeter, then 14,710 is how much centimeter? So it will be 14,710 divided by 6,600. That is almost equal to 2.22 centimeter. So we have to draw 2.2 centimeter above A, keeping scale on that 0, like the A dash point. From there 2.2 centimeter. So this is our A dash. After drawing this, we have to draw a parallel line to output line, that is our O dash A. Whatever the line is, parallel to that we have to draw a line from A dash, or else we can do it as from O dash, again take the length, this is 2.2. So again from O dash take 2.2, just mark a point 2.2 and join the point whatever we marked and A dash, such that it intersects at a point of the circle. So this point is, let us consider it as P. So from point P, draw a line straight down. So this point is T, the down which intersect at x axis is T, point T. After this, as I told, A D is our total losses at block rotor condition. So F to D is our constant losses, that is our stay losses. From A to F, whatever we get, that is almost almost equal to 4 centimeter. That is our copper loss of stator and rotor. So here we have to check whether any condition is given, like percentage of copper loss 50%, 60%, in that way. Here it is not given. So we have to take stator copper loss is equal to rotor copper loss, means it will be 50-50. So here, since it is 4 centimeter, from point F we have to do, since it is almost equal to 4 centimeter, just mark a point up at 2, means half of that. So it will be our point E. So Fe is our stator copper loss and Ae is our rotor copper loss. So from E, draw a line directly towards O dash. So this is our torque line. Torque line. The line what we draw from P to T, here it intersects with 4 lines. Out of that, from bottom if we go, after the x-axis up above that, it will be S, the point will be S, and the above will be R, and above that will be Q. So at the output line it will be Q, torque line R, and the bottom line will be S. After this, now we have to draw 2 lines from point C, which is one line is perpendicular to our torque line, the other line is perpendicular to our output line. So from point C, torque line, if we see here, the perpendicular bisector what we do is perpendicular to our output line. So at this point, since it is perpendicular, in the sense it is 90 degree to our output line and is passing from point C, here we point, make a mark, we will consider it as M, and another line which is perpendicular to our torque line. Draw a line to line such that it is perpendicular to our torque line. Just keep make sure that it is very much perpendicular to our torque line, and just draw touching to the circle and the point C. So it should, we have to keep this on point C and make sure that it is on perpendicular to our torque line. So that point is J. Now we have done M and J, we have marked and put these lines. After that, from point J as well as M, draw a line straight down till our torque line. Since here we made a line perpendicular to our torque line, so from point J, bring a line straight down till the torque line. Other line we did perpendicular to our output line. So from point M, bring line down till it intersects our output line. Since we did perpendicular to our output line, we bring it till output line, and this one, since it is perpendicular to our torque line, bring it till torque line. So mark these points K, N. Now here our output power is at this point. Since it is perpendicular, power at this point. If we draw a line from O to point P, it gives us the input current. This is our input current. O to P is our input current. Now we have to draw a line from point O such that it is a tangent to our circle, means it should touch just the surface of the circle. So this point is H. From H, bring that point down up till our x-axis and mark it as O, not O, I. Mark it as I. Here the angle from our y-axis to till the O dash is phi O, and angle from our y-axis up to our A line, that is output, the block rotor current line, that is phi SC, and angle from our voltage axis to the line PO, whatever we did, that is our phi. After our circle diagram, coming to the calculation, the final calculations. Here we have got maximum output power. So we have to check the output line. Here from maximum output power is our Mn, that is Mn. This is our maximum output power. So here we'll get some length. It will be almost 3.3. So we have to multiply Mn with our power scale, whatever we had calculated. Here we had calculated power scale 1 centimeter is equal to 6000. So power scale here it will be 6600. So we have to multiply that with our centimeter value. In this, maximum output power is Mn, so it will be the Mn value into power scale. Maximum torque, that will be from our torque line. So from torque line, the upper line where it intersects the circle, that is our J. From the torque line to the J, we have to calculate and take the torque value into power scale. So here starting torque is AE, that is AE into power scale, that will be, this is almost 2 centimeter. So 2 into 6600, the power scale, it will be 13,200 synchronous watts. The output power PQ in this diagram, if we see, this is the output power. PQ is the output power, QR is our rotor copper loss, RS is our stator copper loss, and ST is our fixed losses, which does not change. So these values is our normal condition, and these values of the losses is our block rotor condition, where AE is our rotor copper loss and EF is our stator copper loss, and FD is our constant losses, which does not change at any point. So at this normal, we need to find all the normal values. Here PQ, to find output power, it will be PQ. Input power is the whole line, that will be losses plus in the output, it will be PT into power scale. To find the slip, it will be rotor copper loss, that will be QR divided by total input to the rotor, not the total input to the motor, it will be total input to the rotor. The total input will be PQ, that is the output, plus QR, the rotor copper loss. So that is PR is the total input. Rotor input is whatever we give to the rotor, it will be PR, PQ plus QR, that is PR, rotor input into power scale. The rotor copper loss is QR into power scale, stator copper loss is RS into power scale, stray losses, that is constant losses, will be S into ST, that value, into power scale. So we have to measure it in scale and multiply into the power scale in order to get all the values in terms of watts. Motor efficiency will be PQ divided by PT. So here, since it is motor efficiency, we are taking the whole input value as PT. So rotor efficiency, it is just about the rotor. So the output will be PQ divided by input, that is PR, the output plus the rotor loss, that is QR. So it will be, total will be PR. The power factor will be cos phi, that is PT divided by OP. So this is our power factor at normal condition. Input current is OP into current scale. The OP value, that is almost 3.2 into current scale. Our current scale we have taken as 1 centimeter is equal to 10 amps. So it will be 3.2 into 10. Maximum power factor, it will be, since we have drawn a tangent which touches the circle at point H, so it will be HI divided by OH. So this is our maximum power factor.